Hello again, and welcome back. Today, I continue the explanation of language acquisition using pattern theory. Last time, we saw how words connect to meaning based on patterns. Today, we see how phrase patterns continue along these same lines. In some ways, this effectively makes NLU a little like the Enigma puzzle of World War II, in which our history of study of semantics and language come together to solve the puzzle. Here, any pattern based on our observations of language must be considered and tested to validate our model. After our theory today, I will take you under the covers of our meaning matcher to show how the theory aligns with the engineering. You can also get a feel of the performance in using the tools over a network. In this case, our hosted server is working over an ocean, so the API can service my screen. As usual, you can select the specific part of the video in the contents area or read the article in Medium if you prefer. Okay, today it's going to be fun. What we're going to do is look at the phrase patterns in language. So phrases are sequences of words, and words have to change in order to accommodate phrases in different languages. So we're going to look at how natural language understanding takes advantage of both the difference in words and the phrase sequences that are encountered. And we're going to focus on English today because that's the one I happen to know, and no other ones as luck would have it. Last time we saw that all you have to do is connect the sequential sound, so the sound patterns in language, with the meanings in order to start to build up language. And the reason this is fun is because once you have those meanings connected to sounds, when you start playing the sounds in sequence, you also have the patterns from the meaning. And that's how the bootstrap process continues, and you'll see more of that shortly. And we also talk about, instead of the poverty of the stimulus making it hard to learn a language, you have a plethora of meaning. There is so much meaning to deal with once you look at the meaning of particular words. And so we can take advantage of that meaning plethora in order to progress. Now, people have always wondered what's a word and what's a phrase? And the answer is, in our NLU at least, we don't want to make any preconceived ideas. It appears that you can have phrases which are sequences of words, and you can take the Wizard of Oz there as an example. And the Wizard of Oz, you can't substitute the words without losing the meaning, which is it's either a book or a movie. But if you kick the bucket, or if he kicked the bucket, they're different words. So the particular word that you're using relates to the meaning. And there's going to be variations in between. So in another example, you can see cats eat rats. That's very generic. You could swap in many words into those different positions and still finish up with a valid meaning for the predicate. And of course, with embedding, one of the features of language generally, but not for all languages, is the ability to take a whole sentence and bundle it back inside another sentence. So in that example there, the large cat saw the rats the dog chased. What we do is we first extract the fact that the dog chased the rats. That's a semantic representation that we can then carry forward into this conversation. But we also know that the large cat saw the rats. And which rats were they? They were the ones that the dog chased. So all of that information comes to bear on NLU. And you can see there's different types of phrases. So we don't want to be too specific about anything. So our working definition, it's either the literal words, meaning elements, attributes, and any combination of those things that make up a phrase. So for English, the words themselves are modified. So you can see there, eat and eats are both examples of the concept of eating, and cat and cats are either one or more than one of that particular type of animal. So we'll now look at how you go about learning that type of pattern. So on the left-hand side, we've got some singular examples, the cat, the dog, the car. On the right, we've got plural examples, the cats, the dogs, right the way through to cats. And in order to learn that, takes children a year or so, I think, to start to get to use these correctly. But you can see that the meaning of each of those phrases is actually the rightmost word. So the cat is a cat, the truck is a truck. And when you drill down to what truck means, it can actually be a number of different dictionary definitions, but fundamentally it's not the meaning of the word the. And in terms of cats, we also keep the right-hand element, but that S isn't relevant for the meaning. It's providing us with the fact that it's plural. So we want to be able to retain the fact that it's plural, and then we'll retain the fact that it's a cat or a dog, whichever one we have in that example. And also worth noting is that the sound that you make for that S varies. In the case of cats, it's the S sound. In the case of dogs, it's a Z sound. And there's lots of examples where you think you've got a standard rule, but it really depends on the rest of the word that goes into it. Okay, so what the meaning matcher does is it takes those examples and it simply replaces the meaning of that rightmost word, and it adds an attribute of singular. In fact, it gets the attribute of singular from the word itself. And in the case of cats or dogs or cars, the plural version, we keep the right word meaning again, and we add the plural, which also comes from that particular form of word. Predicates now are going to extend this concept. So you've got the cat eats, the dog eats. So we're now changing that word for eat by adding an S sound to the end for the singular version, and the plural version actually does the opposite. The cats eat, the dogs eat. And this helps us disambiguate or understand what the referent is in sentences. So in the same case, well, in this case, we're going to keep the rightmost element. So we're going to keep the predicate eats or moves or stops. What else have we got there? Sheds. We're going to keep the rightmost element, and then we're going to take the meaning of the start of the sentence as the privileged syntactic argument, the PSA, and we're going to keep that for use when we actually use our linking algorithm to produce the meaning. And it's the same singular, plural. Obviously, the pattern is different. In the case of singular, we have the S at the end of the word eat, and in the plural example, we don't. So there's a system that we're going to use. We're going to track the PSA as well as retaining the meaning of eats. And when you have more complex sentences, that's our method for building up this thing called a consolidation set. So you can read that, but fundamentally, there's our system for tracking this simplistic referent and a very simplistic predicate without going to the end of the sentence. And you can learn this from induction. For our NLU system, we're not learning from induction because it's kind of trivial to add the singular and plural combinations for our reference, and for the predicates, it's the present tense that we're also tracking, as well as the person. In other languages, obviously you have gender, and in our systems that deal with those other languages, we would treat those accordingly. But quickly, we'll move into RRG. So the role and reference grammar has a very large number of attributes, which when you go through the whole list of abbreviations, you can find attributes that only apply to specific languages. But if you look at thousands and thousands of languages, you can find the commonalities through RRG. And in the case that we've looked at so far, you've got from the arrow there the number and the fact that it's present that we've been picking up on, and there's also a person element that you could pull out of there. So that's the point of having a linguistic framework to work with. It's going to make life a lot easier when you get to new languages, knowing that the elements that went into your first language are going to be reused in these other languages. In general, certainly the meaning-based ones will be. Also now, there's this concept of an operator that comes into the clause. So the clause is the proposition. It has an illocutionary force, so it's either a question, a statement, or a command. And there's a lot of detail that has gone into the RRG propositions or clauses, which is the syntactic term. And then the image on the far right is looking at noun phrases, or what we're calling the referent phrase, the argument that's being used in a larger sentence. So here's what our sentence is looking like now. You've got the cat eats the rats, and because we know that the word is now mapping to its meaning, we could have a bunch of meanings, and connected to those meanings, they're going to be an operator, a referent, or a predicate. An operator is just a special type of meaning. And we also have this other information that comes from the word itself. Cat is singular, rats is plural, eats is present tense. So that type of information is all available through the network, but that's not the best way of looking at it. What we would do instead is look at it this way. And you can see that from the top, the cat eats. We know that the is an operator, cat is a referent and singular, eats is predicate, present and singular. And the way we do that in our networking system is we simply look at all of the meanings, and then we do a union of the components so that we can do a phrase match. Because obviously as we refine the meanings, we're going to have fewer and fewer elements. Now the green bits there represent the phrases that we're matching in order to consolidate that sentence. So we've got operator and reference singular, for example, to match the cat. And that phrase is connected. In this case, it would be connected to operator if that were the attribute, so that if we don't have an operator there, we're never going to check that particular phrase because that phrase is never going to match. Equally, if it's a referent and singular, we're only going to be looking at that phrase if the current word is referent and singular, because we're indexing that in our network off the attribute, not off the word cat. And this is our way of generalizing as well, by connecting the phrases to the attributes at that particular point in our meaning match. So here's going to be an example. So we see the cat. We match this as it's a singular cat. So we're going to store the meanings, in this case, the meanings of cat plus that attribute singular. That's our first phrase. Then the fact that we have that singular referent, we can now match it with the word eats, which is predicate, present, and singular, and that phrase is then going to retain eats, as we just said. And then we've got a third phrase which is going to match the rats. So the meaning of the second one is going to be eat, singular, plus a reference to that PSA, the privileged syntactic argument, which is the meaning of cat, and then we're going to add in as the direct core argument the rat, which is also plural. And that's our consolidation set. So fundamentally, we're retaining the semantic representation of these reference that we get when we have these embeds, and we're creating a consolidation set. It's not like a parser, which would simply be pushing through based on parts of speech. We're actually retaining the meanings of these words as we go, and we're also retaining those semantic representations. And I've already said that the phrase efficiency is very high, because by connecting the phrases that you test to the current attributes, you're not testing phrases that aren't current attributes, which means you don't have to test a very large number. So, for instance, as you have attributes that relate to particular types of phrases, you only have to check those particular types of phrases. Okay, so here's another simplified view. The cat, we're matching cat plus singular. Then we see eat, so we've got that predicate eat, which is the meaning of eats, plus singular because it's the singular form, plus PSA, which is the representation of the cat, which we are going to use in order to get our logical structure. Then we match rat plus the fact that it's plural because it's rats. Then we're going to match that direct core argument, rats, with eats, because eats, which already has the PSA embedded in it, now is going to get the direct core argument as well. So now we've got a consolidation set with the syntactic elements, and based on that, we can now match and use our linking algorithm for this particular type of predicate, and we get what you can see there, the logical structure for it. And in fact, in the real world, you'll see this is an active achievement, and we're going to get another meaning-based element. All right, let's start and have a look at the output of the meaning matcher so you can get a better feel for what we've just been discussing. So first, we're going to go to the meaning matcher screen. We've got the cat ate the rats. This is a past tense version, but it's just going to show you what to expect. And here we've got the text that we've entered. The cat ate the rats. It's a statement, it's positive, and it's past because it's ate, not eats. Down here we've got the logical structure. The cat is the thing doing something because this is an activity, and in this case the cat is the actor which does the eating and the eating of the rats. And we have this active achievement where at the end of that activity the rats have been consumed, but we'll cover that in more detail another time. Notice here that the meaning of eats or ate is this thing eat 6, which means take in solid food. So this is our disambiguation in process as well. So let me just change this to the cat bites, no, eats the rat. So it's unambiguous the cat eats the rats. And when we look at the meaning matcher output, what we see is its positive statement is now present because it's eats. Notice that the meaning of bites, no, eats is in fact eat, so take in solid food. The same as the past tense meaning, because the tense is in fact just an attribute of the particular word. So that's the resolution of human backtracking in action. But probably more interesting for you today is, I'll just get rid of that, is the link output. So here I'm going to go to the cat eats the rats, and we'll look at the result of the meaning matcher under the covers. So here we've got the particular words that have been recognized. The cat eats the rats. And here we've got the different phrases. So we could either look at them that way, or we can go into the detail and drill down properly. So there's the word itself. We match then the cat, which, apologies for the old terminology. These phrase names are just things that we use for debugging and for seeing what we're working with, because otherwise it's just those little X's that we saw on the network last time. So we've got here the cat, then the cat eats. So we've recognized now a predicate, and we've stored our privileged syntactic argument, the cat, and then we've added the direct core argument. We're using the old terminology here. And then we get 2 predicates that we can use. And of course, in language, you use the longest one that matches all of the words. So when we look at this last one, you can see that this is the full sentence. So that's the meaning matcher in action. I might just show you one more thing, because it's sort of an obvious point, but the rats are eaten by the cat. So here's a passive sentence, and it should give us exactly the same output that we just saw. So here we've got still statement, positive, present. We've got the cat is the thing eating the rats. Eat is the main idea there, so you can see it's still taking in solid food. And then we've got a cat as the actor and the rats as the undergoers. So that's passive, and it's important in context, but it's also important in understanding a sentence to recognize it correctly. So that's it. The end of the 2-part overview of language acquisition based on brain theory. As an engineer, and with the tools available, I think we will continue to build a dictionary with linguists, expanding on the work of visionaries like George Miller to allow us to integrate multiple languages on the one semantic network. There's some benefits to that. And next time, join us again to see how our experience with a Facebook AI research group set a good test to improve our semantic network in our efforts to surpass current machine learning capabilities for NLU.